Hello everyone, this is my ninth video lecture on infinite series. In this video, we shall consider some examples where we will be checking the nature of the given series of positive terms using the ratio test or the D'Alembert's ratio test. So the first example is to examine the nature of 1 square by 3 plus 2 square by 3 square plus 3 square by 3 cube plus dot dot dot. So here how to proceed? So let us proceed here. The given series is summation un. So we have to consider summation un. We should write like let summation un be the given series. Here we have to find out the nth term, that is very important. So un is, when we observe the given series, in the numerator the terms are 1 square, 2 square, 3 square. In general, in the nth term it should be n square. This is very easy to identify. In the denominator the terms are 3 to the power 1, 3 to the power 2, 3 to the power 3, respectively in the first term, second term and third term. In generally in the nth term it should be 3 to the power n. So this is the nth term we have identified very easily in this case. Now after finding the nth term, we have to go for un plus 1. According to the so-called ratio test, we have to find out what is n plus 1th term. So finding n plus 1th term is very simple. Wherever n is there, replace that by n plus 1 and get the n plus 1th term, that is un plus 1. So it is 3 to the power n plus 1. Now what is according to the procedure of ratio test? Consider un plus 1 divided by un. So first let us write down what is un plus 1. It is n plus 1 whole square divided by 3n plus 1, 3 to the power n plus 1. So we have written the numerator here divided by, I am writing whole divided by, the denominator is n square divided by 3 to the power n, or in a simple way how to write, keeping the numerator first as it is, the denominator, it is better to write the denominator in the form of its reciprocal directly in the numerator. So this is a preferred way of writing un plus 1 divided by un. So the same thing we will be following for our further examples. So this is un plus un plus 1 into the reciprocal of un, that stands for un plus 1 divided by un. So writing un plus 1 divided by un is so easy. Now we have to simplify the terms. So how to simplify the terms? Take these terms, similar terms on one side. So this is equal to, first it is n plus 1 whole square divided by n square. So these type of terms we have grouped, and this is 3 to the power n divided by 3 to the power n plus 1 can be written as 3 to the power n into 3. So by the properties of indices we can write like this. Now 3 to the power n, 3 to the power n cancels, so it is only 1 by 3 remaining, 1 by 3 outside. In the bracket we shall take n plus 1 divided by n and whole square of that. So this is un plus 1 divided by un. Now we have to apply limit on both sides. So consider limit as n tending towards infinity of un plus 1 divided by un on LHS. Whereas on RHS, again we should write limit as n tending towards infinity of 1 by 3 into the bracket n plus 1 whole square, n plus 1 divided by n whole square. Now it is convenient if we divide separately. N by n is 1 plus 1 by n. So that we can do. So this implies, when we simplify, this is going to be 1 by 3 can be taken outside the limit. Now n by n is 1 plus 1 by n whole square. Now when we apply infinity here, what will we get? 1 by 3 as it is into the bracket. Here it is 1 as it is, plus this is 1 by infinity is 0. It's a square. So 1 plus 0 is 1. 1 square is 1. 1 into 1 by 3 is 1 by 3. So we are having the limit as 1 by 3. 1 by 3 is a number less than 1. When the limit is less than 1, when we compute limit of un plus 1 divided by un and get the answer as less than 1, therefore by ratio test it implies the given series summation un is convergent. So this is how we have concluded at the end that when the limit obtained is less than 1, according to ratio test, the given series is convergent. So with this, the first problem completes. Let us consider the second example. Here we have to test the convergence of 1 plus 2 square by 2 factorial plus 3 square by 3 factorial plus 4 square by 4 factorial plus dot dot dot. And we can observe here that the first term 1 can be written as 1 square divided by 2 factorial. So in the first term, so let us consider let us consider the given series as summation un, and that we shall write it as 1 square by 1 factorial. 1 can be written like this, plus the remaining terms as they are, 2 square by 2 factorial plus 3 square by 3 factorial plus 4 square by 4 factorial and so on. Here directly by looking at the terms we can conclude that the nth term is n square by n factorial. It is very, very simple. 1 square, 2 square, 3 square, in general n square. 1 factorial, 2 factorial, 3 factorial, in general n factorial in the denominator. So after having this, we have to go for finding un plus 1. So un plus 1 can be found by taking n equal to n plus 1 in un. In un, wherever n is there, let us write n plus 1. So it is n plus 1, it's a square, whole square, divided by it is n plus 1 factorial. Now after that, consider un plus 1 divided by un. So first we should write this directly as it is. We are writing un plus 1 in the numerator, that is we are directly writing it as it is. Un is to be written in the denominator. Instead of writing that in the denominator, we can write the reciprocal directly in the numerator. So reciprocal of un is n factorial divided by n square. Now our duty is to simplify the RHS. So first these factorial terms can be taken together. So let us take n factorial first divided by n plus 1 factorial can be written as n plus 1 into n factorial. This is one of the known results. We know one important thing, that is k factorial. If we have, that can be written as k into bracket k minus 1 factorial, and that we have used n plus 1 factorial we have written it as n plus 1 into 1 less than this, that is n factorial. Just like by using this property we have written this thing here, into the remaining terms n plus 1 whole square by n square, n plus 1 whole square by n square. Now this n factorial cancels, and 1 n plus 1 bracket cancels with this n plus 1. So the remaining thing is n plus 1 in the numerator, in the denominator it is n square. So this is the thing remaining, and we have to apply the limit. We have to apply the limit on LHS and on RHS. This implies limit as n tending towards infinity of un plus 1 divided by un equals to, on RHS also, limit as n tending towards infinity of n plus 1 divided by n square. So it is simple, by separately dividing we can proceed. Limit as n tending towards infinity of n by n square is 1 by n plus 1 by n square as it is. So the final answer 1 by infinity, we have to substitute n equal to infinity. 1 by infinity 0 plus 1 by infinity square is again infinity, 1 by infinity is again 0. So 0 plus 0 is equal to 0. 0 is a finite quantity and it is a number less than 1. When the limit of un plus 1 divided by un is less than 1, we can conclude hence by ratio test, summation un is convergent. So this completes the second problem. Thank you.